Hello there. We are going to be doing video 12 and 13. There's really only one video, but when I planned for the class, I separated them into two. So we're going to count this as both. So this is video number 12. It's also going to cover video 13. And this is going to be chapter 3, section 6. And chapter 3, section 7. All right, and this is all about writing equations of lines. Now, there are 3 different ways for you to write an equation of a line, and those 3 ways, let's just state that there are 3 different ways. Linear equation. Can you fit this all in one line? Yuck. Okay, so the first way is a way that you are very familiar with and comfortable with, at least should be. I'm trying to get rid of this stupid box. Why won't that box go away? There we go. Okay. Those really irritate me. I don't know if they irritate you, but they drive me crazy. So the first way is slope-intercept form, which we're already familiar with. It looks like y equals mx plus b. But let's make a couple of statements over here. M is the slope. We know that already. So it's like a coefficient on the x variable, right? That's the slope, always attached to the x. B is the y-intercept on the graph. Oh, I'm getting a little squeezy here on the right-hand side. So M is the slope. B is the y-intercept. And I don't know if you've ever been asked this, but the remaining x and y in this equation, literally variables, right? So they represent, do you know what they represent? They represent all points, ordered pairs. Oh, there's an S in there. All points on that line, right? As an ordered pair, XY. So they don't change because the point changes as you move up and down the line. Hence the word variable. It is variable. All right. So the reason that we use this is the best way to graph a line. Right? If you want to graph a line, this is the most effective way to do that. If you don't have a formula already in that form, you want to put it in that form. Just solve for y. All right, the next one, number 2, is called point slope form of a line. There should be a hyphen in there. Point slope form of a line. And it's exactly what it sounds like. This is best used when you have the slope and one point or a point on the line. Okay, this is the best time to use this. And this is what it looks like. The formula is y minus y sub 1 equals m times the quantity x minus x sub 1. And you will fill in these pieces, the m, and then the x1 and the y1 is the given point. Okay, so you don't change the x and the y variable, just like you don't change the x and the y variable up here in slope-intercept form, right? They stay in the equation. So will these ones. I don't know why that's jumping all over the place. So the x1, y1 is the given point. So you will have that in the problem. M is the slope. And the x and the y stay in the equation. And we'll take a look at how to utilize this in a little bit. The third way to see an equation of a line is in what's called standard form. This will be in our next video. This is going to be chapter 3, section 8, and it will be covered in the next video. But the idea here is standard form of a line looks like ax plus by equals c, where A and B are not 0, are both not 0. One can be, but the other cannot. None can be fractions. Oh, I spelled that wrong. Fractions. There we go. And if you were doing this test for me, I would also tell you that A cannot be negative, but Varsity doesn't care. So I'm not going to be terribly picky about that. Okay? We're going to talk about that, like I said, in the next section. All right. So moving on along. In what section? 3.6. Questions 2 through 4. So 3.6. Questions 2 through 4 look like this. Given a slope and a y-intercept, write the equation of the line. They don't tell you that equation of the line. Hold on, I can't talk and write at the same time. They don't tell you, but the intention here is that this is going to be in slope-intercept form. Okay. And so this really is as easy as it sounds. If you're told that m is -3/4 and b is 1/2, you know that slope-intercept is y equals mx plus b. Just fill stuff in. M is -3/4. The x doesn't go anywhere. B is 1/2. That's what you're going to type into Varsity, although it might actually look like this. Y equals a box. So you ignore this part because it's right there, and you just put in the part that you manipulated. Okay? That's all that is. All right. The next one, questions 5 and 6. These say, given the equation of a line, state the slope of any line A parallel to or B perpendicular to the line. And then it looks like this, A and B, and you just have to fill in. Really, all they're looking for, the important word here is slope. They're not looking for the entire equation of the line. So this is simpler than people want to make it. So quick reminder, we talked about this earlier, but parallel lines have the same slopes, right? And so if you know, here's the equation of the line. From that equation, you know the slope is -5. And so any line parallel to it is also going to have a slope of -5, right? They're exactly the same. And perpendicular slopes are opposite reciprocals. Again, we covered this before. Opposite means sine. Reciprocal is the flipped over fraction. And so if the parallel slope is -5. This is -5/1. You're going to flip it and change the sign. The perpendicular slope would equal a +1/5, right? Flip this over and change the sign. That's all you have to do for those. Okay? All right, the next one you may or may not have utilized before. This utilizes point slope. So this is questions 11 through 13. And it says the slope and 1 point on a line are given. Are given. Find the equation of the line in slope-intercept form. So a lot of finding lines are just manipulating the information that you have. So here's what you're given. You're given a point, and you're given a slope. And what you're going to do is start in point slope form. Remember, you use that when you have a point and a slope, right? Just like it says. So that equation looks like y minus y sub 1 equals m times x minus x sub 1. Recall that the point given is x sub 1, y sub 1, and you already know your slope. So let's just plug some stuff in here. So we have y minus y1, y minus y1 is 4, equals m is 2, right? It's right here. And then x minus x1 is a -3/4. So make sure that you either put in a +3/4 or minus a negative. So I'm just going to flip this real quick. Oh, I forgot to put the 2 in here. This should be a 2. So 2 times x plus 3/4. All right, now I'm going to put a link here to a video. If you do not know how to use your calculator to do fractions for you, watch this video, all right? It's going to become a link somehow. I'll do that after the fact, I guess. I don't know how that's going to happen. Maybe I'll just do the link in Google Classroom. That's probably the best way since I'm saving this video. All right. So let's see. From here, you're going to distribute. So we have y minus 4 equals 2x plus 6/4. Again, use your calculator to do that math. We want this ultimately in slope-intercept form, right? That is the goal for this equation. You were told to find the equation in slope-intercept form. So that means I need this thing in y equals mx plus b form. So I need the y all by itself. So the 4's got to go. So I'm going to add the 4 to both sides. Again, use your calculator. This ends up being 11/2. And that is the slope-intercept form of that line. This does not have to be a nice, happy, even whole number, okay? But you do need to know how to use your calculator to tell you that it is 5.5. If you had to graph this line, you'd have to plot your y-intercept, not at a whole point, okay? All right, and then, so this next statement goes for the 8 questions in 3.7, which is all about parallel and perpendicular lines and slopes. And essentially, here's what they're going to give you. All 8 questions. You're given 2 points. Just as an example, 5, 1, and -6, -3. And then you're asked to find the slope of either the parallel any parallel or perpendicular line. And it'll be specific in varsity. It'll say one or the other. So your methodology here is going to be to use the slope formula. Right? You're going to find the slope. And if you need the parallel slope, well, parallel slopes have the same value, right? So it's the answer. To that piece of information. If you need the perpendicular slope, oops, can't spell this morning, not enough coffee. Then you need to just take the opposite reciprocal. I didn't figure I needed to go through all of that and look at varsity and do a question and all that good fun stuff. So that takes care of 3.7 as well. All right, kiddos, toodaloo.